Okay, what we're going to talk about now is a model with incomplete markets, and what we're going to do is um, continue. Um, this is a continuation of an earlier lecture that we had, where we talked about a baby's kind of my homemade version of a model of Bisin, Clementi, and Gottardi, in which, unlike them, I had complete markets. And I did this to set the stage for presenting their real model, which was an incomplete markets model. So the physical setup is going to be identical with that earlier lecture, but the market structure is going to be different. So let's get going. So the key difference is, instead of being able to trade equities and a full set of aero securities, the agents, which are firms and two types of consumer, they can only trade equity and a bond. Why? Because Bisin, Clementi, and Gottardi say they can only trade that. So we're going to shut down a very large number of markets, all the markets in aero securities, and create an incomplete markets model. And this is going to be a kind of our first encounter with the flavor of Robert Lucas's statement that all complete markets models are alike in their structure, but all incomplete markets models are incomplete in different ways. And this is how the BCG, Bisin, Clementi, Gottardi's models incomplete. You can only trade an equity bond because they say so. So in the complete markets model, we described a version of the classic Modigliani-Miller theorem that said that the firm's financial structure was a matter of indifference to it. It didn't care whether it issued bonds or the division between bonds and equities was irrelevant to the firm, but it's going to matter now. It's going to matter in a subtle way. So several things are going to happen here. There's going to be firms' portfolio choices are now going to, in the Modigliani-Miller theorem, they were indeterminate, but here consumers' portfolios are going to be determined. They're going to be determinate. And what's going to happen is in the complete markets model, there was a sense in which there was a stochastic discount factor, and it was unique. But here, there's going to be different stochastic discount factors associated with different agents, and those different stochastic discount factors are going to price different assets. So a telltale sign of this incomplete markets model is there's not going to be a unique equilibrium stochastic discount factor. There's going to be multiple ones, and agents, consumers are going to have different stochastic discount factors. That's going to matter. There's also going to be, if we have time, there's going to be a subtle version of a Modigliani-Miller theorem, but it's going to be very restrictive. The aggregates of firms' financial structures are determined. In previous lectures, we've talked about big K, little k analysis. Here it's going to play an even more prominent role. Bisin, Clementi, and Gottardi, I'm not even sure that they mentioned big K, little k, but it plays a big role. And they talk about what they call rational conjectures about price functions. And the way that's we're going to dress that up as big K, little k. So that's where we're going. So one benefit of our making the baby complete markets version of their model is the setup. You can go fast over the setup. It's going to be the physical setup. What the endowments, the technology, what firms want to do, maximize the value of the firm. What consumers want to do, they want to maximize their utilities, their utility functions. They're all going to be the same. So I go over that fast, just a reminder. So the economy is going to last for 2 periods, called 0 and 1. I guess I start with 0 because I'm a Python person. There are 2 types of consumers named 1 and 2. You could think about what happens if there's more types. There's this random variable epsilon. It's a scalar, and we're going to use it to generate correlations between the earnings on a firm, what a firm sets, its capital, and the exogenous second period endowments of the 2 types of consumers. And by changing how these endowments depend on the random shock, we're going to generate motives for risk sharing between the 2 types of agents. So in the complete market setting, there's a great vehicle or class of vehicles for risk sharing, and that's those aero securities. You can write virtually any insurance contracts you want. But now we have just, because we wanted to, completely shut those down. No explanation. So in the incomplete markets literature, often these are exogenously shut down. You're going to see this over and over again. So we do that. So that means the risk sharing arrangements are very crude. All an individual can do is decide whether he or she wants to hold bonds and issued by a firm, a certain type of firm, and equities. And they could just change the fraction that they hold. Okay, and the household's going to be a price taker. We'll see, and there's going to be a sense in which the firm it's not a price taker. It's a price function taker. It's a price function taker because it influences the value of its equity and the price of its bonds by its financing decision. Okay, ownership. It's going to be the same that we had before. People own a times 0 endowment. They own shares of a representative firm, theta 0I. Their time 1 endowment is random. It depends on the disturbance, epsilon, the shock, and people's. We're going to following Bisin and Clementi and Gottardi. The way these second period endowments depend on the shock are going to be different for the different people, and that's going to generate. That's going to end in equilibrium. It's going to end up making them have different stochastic discount factors. So that's a key thing. Okay, the aggregate endowments. Well, we're just going to add up the individuals. Feasibility, it's the same. Consumption to the 2 types plus capital invested in a firm. It's going to have to be the sum of the endowments. That's feasibility to the economy. Second period sum of consumptions is going to be the sum of the endowments plus the earnings on the on the firm's investment in capital. Somehow all those earnings are going to be, that's feasible. And we're going to adopt the same production function and the same random shock structure. The shock distribution, we're going to make it normal. Okay, preferences. We're going to have a power one period utility function. You have people, each type wants to maximize expected utility. They're going to have rational expectations, so that G that they're integrating with respect to is the one it actually governs. Now, risk-sharing motives. The two types of agents, period one endowments, have different correlations with the physical return on capital. And that gives them a motive to be concerned about hedging their risks. But the only way they can hedge is by holding positive amounts, non-negative amounts of bonds and equity. We do not allow, following BCG, we do not allow them to go short on either bonds or equity. That's our counterpart of the borrowing limits that we had, the natural borrowing limits. They're much stricter now. Okay, as before, this is going to play a really prominent role here. We have measures of agents and firms, and there's two types of consumer, type 1 and 2. We're going to name them omega as before. Big C is going to be the average the integral over the little c's. And that's going to be true for the first period component and for the second period component for every epsilon. And we're going to do the same thing for firms. We have the zeta, and there's going to be a big K and a little k. And there's going to be a big B for bonds and a little b for bonds. Okay. And it's going to be important later. So we're going to use this big K, big B, little b, and so on to make our individual consumers and individual firms be price takers. So the key thing here is an individual consumer. This bullet point would have been just like it was in the complete markets lecture that we had earlier. But the second bullet point is a little different. An individual firm, it's going to take its infinitesimal part of K of Z and V of Z. It's going to choose its infinitesimal part of this and this, taking pricing functions as given. So its choices of little k and little b are going to influence its prices, but not the pricing functions. The pricing functions are going to depend on big C's and big K's. Okay, so however, equilibrium prices are going to depend on these objects. Okay, this is what we're going to have to keep track of, and that in a model like this. And then we're going to call an equilibrium symmetric, and we're going to confine our attention to symmetric equilibria. If all types of consumers I choose exactly the same consumption profiles, they choose exactly the same. So then little ci of omega turns out to be, in the end, equal to big C for all omega. So in the end, every little c is equal to big C for all omega. And let me make a remark here. In macro, in the Lundquist Sargent book, lots of the papers throughout macro by people like Lucas, Keogh. It's understood that there's a continuum of measure 1 between 0 and 1, and it's not even this little omega is off. It's even forgotten, but it's really there implicitly. Okay, so you'll actually see me do that in other lectures. I'll forget the omega. All firms choose the same level of little k and b in a symmetric equilibrium, so that little k of zeta is equal to big K, little b of zeta is equal to big B for all zeta in that interval. And we're going to restrict ourselves to symmetric equilibria here. Okay. Okay, so now we're going to move on to acid markets. This is going to be important. So markets are incomplete. So ex cathedra, we, the model builders, are declaring only equities and bonds issued by representative firms can be traded. We're making that up. So now we're going to let theta I and this thing, chi I, be consumer of type I's post-trade holdings of equity and bonds, respectively. That's what they choose to hold, equity and bonds. So that's the decision barrier. So the firm is going to issue bonds promising to pay B units of consumption at time 1. It says no matter what, but doesn't. It says it'll pay it that amount if it's not bankrupt, and it's going to purchase K units of physical capital at time 0. That's what it's going to do. So when the proceeds of time at time 1 are less than what it promised, the firm defaults, and its output is going to be divided equally among the bondholders. So when the productivity shock is less than this critical value epsilon star, if it's too low, the firm defaults on its debt. So we had the same thing in the complete markets thing. When we allowed the firm to issue equity and debt, but we also had Aero securities being traded among the consumers and the firms if they wanted. But this time, there's going to be only equity and debt. The payoffs, second period payoffs to a firm that has K capital and B units of bonds is going to be the maximum, these two numbers. If the shock is too low, the equity is worth nothing, continuation equity. Otherwise, it gets earnings out of this. So by issuing bonds, it's actually making the equity riskier. Just think about that. By leveraging up, it's increasing the risk of this. And then here's the payoff second period to bonds. It's either pays what it promised, 1 unit per bond, or it pays less, and so it pays the min. Notice the max and the min. So the firm's going to face a bond price function that's going to depend on both its capital and how many bonds it issues. And the firm's equity is going to have an equity pricing function that's going to be worth Q. That's going to depend on how much capital, physical capital it buys and how much bonds at equity. So key thing is the firm is going to regard this equity pricing function, the bond pricing function, is exogenous in the sense that they're not affected by its own choices. The functions aren't associated. So consumers, what about consumers? They're just going to face equilibrium bond prices. They're not choosing. This is what the firm's doing. The consumer is just going to be a price taker. It's going to face a particular scalar, Q hat and B hat for bonds and equities. Those are just scalars. Now we can turn to the consumer's problem. Okay. So as simple as this is, there's a lot to keep track of. And kind of one lesson is it's more to keep track of than in the complete markets baby model, because that was just a special case of Chapter 9 of RMT 5. Which you just used, not quite a special case, but we had those aero securities that were being traded, and lots of the pricing formulas ended up being very similar to what we've seen before. Not so now. Okay, so with the consumers, as we said before, it's endowed with a W01I in the first period and W1I in the second period, where that's state contingent, and it owns a fraction of a representative firm. And the initial value of that representative firm is V. That's going to be determined in a rational expectations equilibrium. It's an equilibrium object, but the household is going to take it as given. So what's the household, the consumer? We're using the word household and consumer the same. So the household, what does it choose? It decides how many shares to buy of equity and how many bonds to buy. And the bonds that they cost, we're going to let this, whatever this number is, chi I, that's going to be the amount of bonds, number of bonds you buy, and that's the price per bond. That's the price per bond. So the household's a price taker. It's going to take V, or value taker, actually. It's going to take that V, Q check, B check is given. And here's it's going to be its optimum problem. It's going to choose consumption first period. It's going to choose these are things it chooses the first period. It's consumption portfolio, and the second period wants to maximize expected utility, discounted expected utility. Okay, the first period, here's its budget constraint. What it consumes is this is the initial goods it has, the value of its stock and its endowment. That's what it has, and what it spends it on, it buys some equity, okay, and it buys some bonds. And in the second period, its consumption now it's state contingent. It's risky. There's its endowment, okay, which is random. It bought theta I shares, and that entitled to those dividends, which are going to depend on big K and big B. because those dividends aren't, they're going to depend on what the aggregate of firms do and what. So these are big. Notice these are big K and big B. Think about that. And these are the returns on its bonds. It depends on big K and big B. And we're looking at a symmetric equilibrium. So these things are, in the end, in the equilibrium, so this is the problem that the household faces living in irrational expectations equilibrium. And the final thing is we have these no short sales constraints. Those matter. Those matter. Because households aren't going to be in the activity of synthesizing artificial shares and artificial bonds. Okay, from firms. So no short selling. Okay, so very good. So in irrational expectations equilibrium, the Q check is going to equal Q evaluated at the big K and big B, and P is going to be equal to the pricing function evaluated at the big K and the big B. Okay. Okay. So just to repeat, in irrational expectations equilibrium, Q check is going to equal the pricing function, the equity value function evaluated at big K and little b, and P check is going to equal this. So these are scalars, and these are functions evaluated at particular equilibrium quantities. Okay, so what we do is now we're going to form the household's Lagrangian. Check this out. We put a single Lagrange multiplier on the first period budget constraint, and on the second period budget constraint, it's as if I'm putting a scaled Lagrange multiplier, beta lambda 1 to the I times G of epsilon. And that's because that scaled thing is multiplying the constraint, if you notice that, the thing in brackets. So technically Lagrange multiplier is beta lambda 1 to the I epsilon times G of epsilon, the probability. So if we get these first order conditions, we have to get these Kuhn-Tucker conditions, because we have these non-negativity constraints on this. So we have these standard Kuhn-Tucker conditions. So I want you to stare at those. And that's true for each type. Okay, so if you rearrange those, you can do some work and rearrange these conditions, these four conditions. You can boil them down to have the implication that Q check is going to be greater than or equal to, well, this. Now we see that's beta times this ratio is a stochastic, what macro guys call the stochastic discount factor, or finance guys, stochastic discount factor for agent I. And Q check is greater than or equal to this. It's equal if the person is actually holding bonds, holding equity. If the person chooses to hold no equity, then Q check is bigger than this. The right-hand side is what the person is willing to pay for the equity. The left-hand side is the price that he faces. So could be person doesn't hold equity. Same deal for the bond. The bond cost, the equal rational expectations equilibrium bond price is a scalar B check. That's what it costs. This is what agent I is willing to willing to pay for it. Might not be willing to. The left, if the left is bigger than the right, the person sets BI equal to 0. So these are our conditions, and they if you think about them, they open the door to people having different, possibly different stochastic discount factors, and we'll see what drives that. Well, if we stare at these, what these equations are going to apply is that Q check is going to be interrational equilibrium. Somebody's going to have to hold these bonds. Somebody's going to have to hold the equity. So that logic said that Q check is going to be held by the people that value it the most. So Q check is equities are priced by the people who value them the most. If you don't want to hold equity, your voice and what it's worth doesn't register in the market. Same thing for bonds. So look at the max. This is a max over people. So we have you and I may differ about what the value of equities or the value of a bond is, and they get the market's gonna incomplete market's gonna make this max. These are key equations that now it's going to turn out their model is going to have the beautiful property that stochastic discount factors for both types of agents are going to be determined in irrational expectations equilibrium. Okay. Okay. So now we can do some. This is where we're going to do some hard work now. It's kind of a part of the core of the analysis, and where we're really going to use the big K, little k, or big C, little c logic. Okay, so now we're going to do take a decisive step. We're going to turn to what the firm, how the firm looks at things. So when individual firms solve their optimization problem, they take the big C's as fixed object, the big CIs. So in equilibrium, there's going to be stochastic discount factors of the two types of agents. Remember, we're in a symmetric equilibrium. So these big C's are going to be, firm's going to be a price function taker, and these big C's are going to be fixed objects. So the firm is going to use the following logic. It's going to imagine that it faces a pricing function. The firm is completely free to set little k different from big K if it wants, and set little b different from big B if it wants. But that's going to have consequences in that it's going to affect the value of its equity. How's it going to affect it? Via this equation. It's the key thing. This stochastic, it's the type the agents who value the equity the most are going to be the ones who price it. These are the guys who are pricing equity. And if the firm, these are the guys who buy equity, and if the firm deviates from it's the firm. This is the schedule that the firm faces for its equity. Same thing for its prices. The people who value bonds the most are going to be satisfying this equation. So those big C's are defining the equilibrium pricing functions. So the two price functions describe outcomes not only for the equilibrium choices of K and B of this cap, but also the out of equilibrium pairs where the little k's, these are not equal to the average. So this is the key thing. So the firm knows both of these pricing functions. And the firm understands that its choices of KB influences how markets price its equity and its debts. And that's how. So this package of assumptions is sometimes called the rational conjectures about price functions. And if you go read the BCG paper, they give a lot of credit to Makowski for writing several papers that emphasized and clarified how rational conjectures are components of rational expectations equilibrium. Rational conjectures about these price functions. And they're about what agents, the consequences that agents foresee if they deviate from what are their equilibrium choices. Okay. So now what do firms do? So here's the firm's problem now. Firm's problem is to, whoever, everybody wants the firm, the owners of the firm want it to maximize its value because that makes them better off. The way this V appears in the household's budget constraint, meaning the households, even if they're different, because they have different hedging needs, they all want a big value of V. So, so here's the firm's problem. It's gonna issue equity. It's going to issue bonds and it's going to buy physical capital. So that's its value. This is its what it brings in through equity sales. This is what or IPOs, if you want. This is what it issues when it goes to the bond market. And the bond market and the equity market are both looking at the KB choices. So it faces these schedules. So we're going to describe some quantitative examples. They're going to be generated by using parameterizations that are very close to what Bisin and his co-authors use. So in these examples, it's going to be that consumers, they're going to be rigged so that consumers of both types are going to hold equity. But consumers of only type 2 are going to hold debt. Only consumers of price 2 are going to hold debt. Consumers of type 1 aren't going to hold any debt. They're only going to hold equity. And these outcomes are going to occur because we're going to follow Bisin and Clementi and Gottardi, and we're going to set parameters so that type 2's stochastic endowment of the consumption good in period 1 is more correlated with the firm's output than is the type 1 consumers. So that gives the consumer 2 a motive to hedge their second period endowment. And the only way they can hedge is by holding bonds. So they have a big hedging demand. But the way things are priced, consumers of type 1 say, they would, if you ask them, they would say those type 2 consumers are paying too much. I mean, too much for me, because we look at these equations. We look at these equations in equilibrium. So it's going to turn out the type 1 consumer. This type 1 consumer. Yeah, the type 1 consumer is going to say, my right-hand side is less than what the market is charging for these bonds. I'm not going to buy them. I'll just take the risk that I have. Okay. So what this means is that the pricing functions end up satisfying these conditions. And I'm going to stop here, and I'm going to let you stare at these conditions, because, and then I'm going to begin here in the next lecture. This is a great breaking point, because we're ready to analyze what the consequence of the firm's optimum problem are.